Okay, so I want to thank you all for coming here. My name is Arslan Said. I'm the coordinator for Ascension 2021. It's been a really crazy day today with a lot of great experiences. If you're just tuning in now, you're one of the 500 unique visitors that we've had today. And I just want to go over some of the things that we've seen today, just quickly if you're tuning in. So we started off today with a MOU announcement with Zenith Canada. We had the co-founder of Zenith, Tahir Murali, talk about the fellowship opportunity that's available at Zenith Canada. If you're interested in getting involved in space, it's a really amazing opportunity to check out. That's once again Zenith Canada. So check that out if you're interested in getting a fellowship. We've also had an amazing panel discussion with our own Ishan Acharya and our great panelists. That was a great discussion about entrepreneurship in Canada and what you should expect if you're an entrepreneur and want to get involved in space. We've also had great lectures held by Dr. Alex Ellery, who spoke about self-replicating robots, and also Dr. Oz Lozinski, who talked about his work in planetary exploration and his work at the Lunar Gateway Project. So those are really amazing and just fantastic. It's been a really great day. We're moving on to the next leg of our conference today, so this next session is called 3-Minute Thesis. If you guys have never heard of this before, I'll just give you a quick rundown of what 3-Minute Thesis is. 3-Minute Thesis is a speaking competition where participants have about 3 minutes to present their thesis or their project in a concise and clear manner, which is accessible to the lay population. So it's a competition that was started and founded by the University of Queensland in 2008. It started off as a competition held just by one university, but since then it's actually exploded, and now over 900 universities attend this competition annually, and that's in over 85 countries in the world. So this explosion really speaks for the importance of this ability to be able to concisely and clearly explain your research to a lay audience. As you guys move throughout your paths in the space industry, you'll work with a lot of people who won't actually know about your research. The space industry is hugely diverse, and so you'll need to be able to learn how to present your information and your research in a manner that's really compelling and quick. So without further ado, I just want to kind of introduce what we're doing today. So we'll have two judges on the stage, myself and also Katie Harris, who is a director at large at SEDS-Canada. So I just want to introduce Katie really quickly. She's, like I mentioned, director at large at SEDS-Canada. She's also a medical student at the Memorial University of Newfoundland. And I just want to introduce that because if you're somebody who's not from a stereotypically engineering or space background, and you feel like you don't belong in the space industry, or you feel like maybe you don't even belong in SEDS, it's just kind of proof to show you that if you have a passion for space, you really do have a place in space. Like I mentioned before, space is a hugely diverse field. And if you find that you want to get involved more with space, then I really encourage you to maybe go to SEDS-Canada website and apply for any positions that are open, or to get involved with any space projects that are in your area. So, with that being said, I just want to introduce the participants that we have today. So these 6 participants were selected from a hand-selected actually because of how interesting they were. And each one of these participants is going to come on stage in this order to present the unique, interesting topics that they'll be presenting. So we'll first start off with David Souza, who's going to be talking about food cultivation in space. And sorry, just a disclaimer to all participants. If I mispronounce your name, maybe after this conference, just tell me, as somebody from a Middle Eastern background, I totally understand, and I'm sorry in advance. But yeah, so after that, we'll be having Zephyr. We'll be talking about how to finance a space mining operation. Following that, we'll have Ilhan, who will be talking about bio-inspired ceramic shielding for spacecrafts. We'll have Aaron Richardson, who will be talking about telomere dynamics in space. Then Maya, who will be talking about using zircons for geological dating. And then finally, Victoria, who will be talking about COVID-19 sequelae. So with that said, I just want to introduce the first speaker. So Davi, we'll just let you on stage in a second.
Hello, can you hear me well?
Yes, we can hear you.
Nice. So may I share my screen?
Yes. If you, there's a button at the bottom of the screen that you can click. I'll let you share your screen.
Let me see here. Okay. Tell me if you are able to see my presentation.
Yep, you're good to go.
Nice. So, hello everyone, I am Davi Souza, and today I'll be talking about Habitat Marte experience on space food systems to Mars. This is a research conducted by me and Professor Julio Rezende, which is the Habitat Marte coordinator. A brief overview about me: I'm an electrical engineering student and also an astronaut and research at Habitat Marte. And my research background is focused on food production and control in environments and its applications for future space greenhouses. This is the Habitat Marte Mars Analog Station. We are located in Brazilian Northeast in the semi-arid region. We were the first South American Mars Analog Station. We also are an environment for effective training, learning, and informing about space. Also, with focuses to expand human knowledge and share results on Mars exploration and stimulate space research and technologies to improve global sustainability. We are self-sustainable and resilient habitat to perform analog missions and establish the next generation of space explorers. We are also connecting space and sustainability by informing, inspiring, engaging, and impacting youth, students, and local communities. So we have developed the biohabitat greenhouse with a cultivation area of 160 square meters with an aquaponic closed system to meet the food demand during the analog missions. And we cultivate fish and crops. As you can see here, we have the tilapia fillet, the crops that we cultivate, and also a monitoring system for environmental data. We have developed some routines associated to management, maintenance, recycling practices, harvesting and processing related to the habitat management and operation. These are some protocols that we operate there. As you can see here, these are some routines that we developed inside the biohabitat greenhouse, such as water quality analysis, plant health analysis, and other activities. Also, we evaluated the physiological impact during meal preparation and food consumption in our food routines. And we had the result that the greenhouse can be a space to stimulate not resilience and provide a positive impact on the physiological well-being of the isolated crew. So now we are developing some methodologies and processes to cultivate plants in basalt-based soils in extreme environments. And that's all. Thank you very much for your attention, and it's a pleasure to be here. You can contact me by email. Thank you very much.